Dear students, so today we are going to learn about enzyme inhibition. Enzyme inhibition is nothing but stopping the enzyme action by using chemical substances. The chemical substances involved in the inhibition are called as inhibitors. Okay, the type of inhibition is classified into reversible and irreversible type of inhibition. Reversible type is quite complex when compared to irreversible type. So we can have a look of the reversible enzyme inhibition. The reversible enzyme inhibition are having three types of properties. One is increasing the concentration of the substrate. This inhibition stopped by using the concentration of the the substrates, and the inhibitors may be detached. This is called as competitive type of inhibition, and non-competitive, uncompetitive are the different types. So the reversible type is further classified into competitive, non-competitive, uncompetitive, and mixed type of inhibition. All the types we are going to study. The first one is competitive type of inhibition. This is the diagram which is depicting the mechanism of the competitive inhibition. So this one is so this is the enzyme, and so this area is the active site. So active site is a site for binding the substrate. So if you're adding the substrate, this will become enzyme substrate complex, and if the inhibitor is added, this will form enzyme inhibitor complex. Simple. So both the substrate and inhibitors will target the same site. So there is a competition between the binding of substrate and inhibitor. So that is why it is called as competitive type of inhibition. And so the competitive type of inhibition is classified into two different types: the classical competitive type, and another one is non-classical competitive type. And the non-classical competitive type is this one, and the type of inhibition is same, the competitive, but the inhibitor and substrate will not compete for a same site. So the site is different. I'm explaining now. So this is the site of binding of substrate. This is substrate binding site, and this is inhibitor binding site. Once the substrate is bound, the inhibitor site is locked. You can see here this one is modified, so this will not allow the inhibitor to bind. At the same time, if the inhibitor is bound, the substrate binding site is modified. So this broader one is modified into a narrow one. So that is the difference. So the difference between the classical and non-classical: the classical competitive inhibition is the binding of the substrate and inhibitor on the same site, and non-classical competitive inhibition is the binding of substrate and inhibitor in different site, but the binding of one will affect the binding of another one. So this is very simple. I hope you understand the concept of both classical and non-classical inhibition, competitive inhibition. And so coming to the kinetics of competitive type. So here the enzyme, so this is enzyme and the substrate form enzyme substrate complex, and further enzyme substrate complex will form separate enzyme and separate product. This is the reaction. If inhibitor is added to the enzyme, and this will form enzyme inhibitor complex. So enzyme plus substrate will form enzyme substrate complex, and enzyme and the product is formed from the enzyme substrate complex. At the same time, if the substance this inhibitor is present, so this will form enzyme inhibitor complex. That means there is no product formation. So that is the mechanism of enzyme, that is competitive type of inhibition. So here we are going to have the kinetics pattern. So this is a typical one. That is so what is this type? 1 divided by substrate concentration versus 1 divided by velocity. Okay, this is nothing but Lineweaver-Burke plot. Okay, so the pattern of Lineweaver-Burke plot, so it is unique for each and every type of reversible type of inhibition. That is, we have 4 different types: competitive, non-competitive, uncompetitive, and mixed type of inhibition also. Okay, in your syllabus, okay, we are going to study only competitive, non-competitive, uncompetitive. That's all. And here you can see here, okay, the black color line. Okay, so this black color is the control. Control means without adding of inhibitor. So this is the lowest concentration of inhibitor, and this is highest concentration of inhibitor. So if the inhibitor concentration increases, so what will happen? So the straight line, okay, this is the straight line, okay, goes further on the top. So that means if it is changing the direction, but this intercept at, okay, that is y-axis is constant, but this one is varying. Okay, this is a typical parameter for competitive type of inhibition. In this competitive type of inhibition, the intercept at y-axis, that is 1 divided by V max, is constant. Okay, that is the one we have to remember. And finally we can have a look. Okay, that is how we can change, okay, that one, how we can remember, okay, the different types of inhibitors. Next one is non-competitive inhibition. So here the non-competitive inhibitor is it is not competition, that is why it is called as non-competitive. Okay, the inhibitor will bind to either E or ES. Okay, that means inhibitor can bind either enzyme separately or in the presence of substrate also. So this is the non-competitive inhibition. So here this is enzyme having substrate binding site and inhibitor binding site. You can see here this is the substrate already bound, and in the presence of inhibitor, so this will bind here also, and without substrate also this will bind. So here there is no substrate, inhibitor is bound. So this type of inhibition is called as non-competitive inhibition. This is non-competitive inhibition. So now we are going to have the kinetics pattern of non-competitive inhibition. And so next one is the kinetics pattern. Can have a look, okay, here. So this is the control. Control means without inhibitor, and these are the lowest concentration and highest concentration of inhibitor. Now you can see, okay, this 1 divided by V max value, that is the intercept will change. So that means 1 divided by V max will change, but this point is constant. That is, this point is called as minus 1 divided by Km. So what is the meaning? Km is, there is no change in Km, only the V max is going to be changed. Okay, so that is the representation here. And we can go to the next one, next type of inhibition. Next type of inhibition is uncompetitive inhibition. So here I binds only to the enzyme substrate complex. So that means the inhibitor need the enzyme substrate complex formation. The free enzyme will not facilitate the binding of inhibitor. So that is the meaning. So here you can see here, this is the inhibitor binding site. Now this is closed one, and only with the binding of the substrate, so this site is open. Open means it will facilitate the binding of inhibitor. So that means, so enzyme substrate complex is must for the formation of the inhibitor complex. Okay, simple. Then we can come to the kinetics part. So now we can have an example, okay, of uncompetitive type. So here the control, that is no inhibitor, and this is lowest concentration and highest concentration of inhibitor. You can see here, okay, all the three are varying, and here also varying. So that means both the Km and Vmax will vary here. Okay, so that is the difference. Okay, and so this is a table, okay, which conclude, okay, all the three different types: the competitive, uncompetitive, non-competitive. And for your sake, okay, because I gave the order, okay, the competitive, non-competitive, uncompetitive. So if you are familiar with this, the flow, you can change, okay, this one to this one, and this you can keep it in the last one also, no problem. And then the competitive, the Km is increased and Vmax remains unchanged. What is it? Km, there is no change, and Vmax remains unchanged. Uncompetitive, sorry, the second one is 1, and this is 2, and this is 3. Number 2 is non-competitive. This low is the Vmax value, and Km remains unchanged. Okay, non-competitive. Uncompetitive one, low is Vmax and Km. Ratio of Vmax divided by Km remains unchanged. Okay, that means that there is a change in both Vmax and Km. That is very important. If you are forgetting, okay, this point also, no problem. Okay, this is maybe not examination point of view. Okay, this one is very important. So there is a lowering of Vmax and Km. Both Vmax is decreased and Km is also decreased. Again, I am repeating, the competitive inhibition, Km is increased, Vmax remains changed. That is Vmax no change. Non-competitive, Vmax is decreased, Km remains unchanged. And the third one is uncompetitive. So both Vmax and Km are, okay, both Vmax and Km are lowest. That means changed. So next, coming to the next type, okay, that is reversible enzyme inhibition uses. Okay, so this reversible enzyme inhibitors, okay, can be used as a medicine. Okay, that is most of the medicines, okay, can be used, okay, for the inhibitors, okay, can be used as a medicine. For example, paracetamol is a prostaglandin biosynthesis inhibitor, and the inhibition, okay, leads to antipyretic effect, that is antipyretic effect and analgesic effect also. Okay, so next, coming to the next type of inhibition, irreversible type of inhibition. So irreversible means once formed means, okay, that's all. So there is no detachment from the enzyme. The enzyme is totally locked. The permanent covalent bond is formed. So this is enzyme. So this is enzyme, and this is inhibitor. So now so this one is, okay, formed. Okay, that means, so CH2S, okay, reacts with another CH2, and hydrogen iodide is released. Okay, the releasing of Hi, and so you can see here between S and CH2 there is a bond. So this bond is covalent bond, and so this is a permanent one. The inactivation of an enzyme, okay, by iodoacetamide. Okay, this is an example. And so with this, okay, we are going to complete all the different types of inhibition.